Welcome to Chem Time.
Hello viewers, welcome to the YouTube presentation. Today's presentation will be discussing the use of multiple YouTube manometer for calculation of pressure or pressure difference. Now, in the last presentation, we have highlighted the limitations of YouTube manometer as the higher the pressure difference, higher the height of liquid, and henceforth YouTube manometer cannot be used for measurement of high pressure differences. And in the literature, it has been mentioned that this problem can be overcome by connecting multiple YouTube manometer. However, I believe this connecting multiple YouTube manometers adds to the area of the manometer while it reduces the height that is required. However, we take a multiple YouTube manometer and show how the pressure or the pressure difference can be calculated for this particular case. The problem that is taken is the multiple YouTube manometer shown below containing water and mercury is used to measure the pressure of air in the tank. The data on H1, H2, H3, H4, H5, H6 that are marked in the diagram are also given, and it is required to calculate the gauge pressure in the tank. We know the density of mercury is 13,600 kg per meter cube, that of water is 1000 kg per meter cube, while the density of air is 1.2 kg per meter cube. The symbols that will be used for arriving at the pressure of the air in the tank is rho A is density of air, rho M is density of mercury, rho W is density of water. We start from the left limb for calculation of pressure, and the pressure at O will be the dynamic pressure plus the static pressure, that is P1 plus rho E G H1, where P1 is the pressure of air in the tank and that is required to be calculated. The pressure at O and the pressure at O1 are same because both are at the same horizontal plane. So the pressure at O1 will be P1 plus rho A G H1. The liquid from O1 is going to O11 against the force of gravity. So the pressure at O11 will be P1 plus rho A GH1 minus rho M GH2. The pressure at O12 will be P1 plus rho A GH1 minus rho M GH2 plus rho W GH2 minus H3, that is the static pressure due to water, plus rho M GH3, that is the static pressure due to mercury. The pressure at O2 becomes equal to the pressure at O12 because both are in the same horizontal plane. Therefore, the pressure at O12 will be P1 plus rho A GH1 minus rho M GH2 plus rho W G into H2 minus H3 plus rho M GH3, which is also the pressure at O2. The pressure at O22 again is to be calculated as P1 plus rho A GH1 minus rho M GH2 plus rho W GH2 minus H3 plus rho M GH3, that is the pressure at O2 minus rho M GH4. The pressure at O3 is calculated as P1 plus rho A GH1 minus rho M GH2 plus rho W GH2 minus H3 plus rho M GH3 minus rho M GH4, that is the contribution of mercury, plus H4 plus H5 rho Ag. So the pressure from the right limb at O dash can be calculated as the atmospheric pressure, that is 101,325, plus the static pressure due to height H6, that is equal to rho M GH6 plus the static pressure due to height H5 plus rho M GH5. Therefore, the pressure at O dash will be 101,325 newtons per meter square plus rho M GH6 plus rho M GH5. Since O3 and O dash are in the same horizontal plane, the pressure at O3 will be equal to the pressure at O dash. And when you equate these three, we'll get the desired equation, which can be used to calculate the pressure with the values of the density of mercury, density of water, and density of air, as well as the height values H1, H2, H3, H4, and H5. We can calculate the pressure at the pressure of air in the tank as P1 is equal to 291,440 newtons per meter square. Since the required pressure is expressed in terms of gauge pressure, so P1 will be 291,440 minus atmospheric pressure, that is 101,325 newtons per meter square. Gauge is equal to 190,115 newtons per meter square. Gauge is equal to 190,115 by 1000 kilonewtons per meter square gauge, that is 190.115 kilonewtons per meter square gauge. With this, I conclude my presentation. Thank you.
Request you to like, share and subscribe my channel.